Use the squeeze theorem to evaluate the limit as x approaches 0 of x squared cos 9 over x. Right, so this is quite a nasty looking function, and the squeeze theorem is really vital. I don't really know, without short of plotting the graph using technology, you struggle to find a better way of doing it than using this squeeze theorem, certainly in time-wise. The trick with something like this, if you've got a nasty function, in this case a product, and if it's got a sine or a cos in, what you do, even if it's cos of something quite ugly, as in cos of 9 over x, it's clearly going to be a very strange looking function. But the fact that it's cos of something is where you get a natural bound from. That the cos of an input has a natural upper bound of 1 and a natural lower bound of -1. So that's what we use. That's where we get the squeeze theorem bounds from. We're going to build the function. So for the squeeze theorem, what you're looking to do, you're looking to trap this limit in between two other limits that you know that the upper limit is greater than or the same as the limit you're interested in, and the lower limit is less than or the same as the limit you're interested in. And what you do, you show that these two limits, the upper bound and the lower bound, are equal, and then that gives you the actual limit that you're looking for. So you squeeze it in between two limits that end up being the same. So we are looking for the limit as x approaches 0 of x squared cos 9 over x. Right, so as I was saying, what we do, we tap into this bit here, and we'll build up with the x squared in a minute. But what we do, we think about this one. Is there a maximum value of that and a minimum value of that? And clearly it's 1 and -1. So I'm going to write that down. So cos 9 over x, the absolute maximum value that can give you is 1. The absolute minimum value is -1. Right, so now we're just going to build it up into this function. We're just going to multiply everything by x squared. And if you think about x squared, because you do need to consider does anything happen with the inequality, you know that x squared is going to be greater than or equal to 0 for all real x, which is quite handy. So when we multiply everything by x squared, we don't have to worry about flipping the inequality sign. So we multiply through by x squared, and it would say minus x squared is less than or equal to x squared cos 9 over x, which is less than or equal to x squared, right? So we've got our function that we're interested in finding a limit of in the middle, and we're squeezing it between an upper bound function, which is quite simple to find the limit of, and a lower bound function which is also quite simple to find the limit of. If we can show that these two bounds are equal, then we have the value of the middle one. So what I'm going to do is just write down limit, limit, limit. So the lim as x approaches 0 of minus x squared must be less than or equal to the lim as x approaches 0 of x squared cos 9 over x, which must be less than or equal to the lim as x approaches 0 of x squared. So now all we need to do is find these two, one on the left and one on the right, and it should be pretty easy after that. So if you think about it, well, this is just 0. If you don't believe, just look at the graph. Minus x squared looks like that. That's the graph of minus x squared. So as x, I'll just draw the y-axis. As x approaches 0 from either side, the function is approaching 0. So the lim as x approaches 0 of minus x squared clearly equals 0. There's no issue, there's no discontinuity, no gap or anything. There's no issue from either side. It's even defined that the thing doesn't have to be, but it is. So this is absolutely true, and it's going to be very similar for the other one. If we think about x squared, well, that looks like that, and as we go into, as x gets closer and closer to 0, so does the function, and that happens from both directions. So the lim as x approaches 0 of x squared also equals 0, which means 0, the limit that we want, 0. 0 is less than or equal to the limit as x approaches 0 of x squared cos 9 over x, which is less than or equal to 0. So now clearly this middle thing must be 0, and the reason is the squeeze theorem. So dot 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 lim as x approaches 0 of x squared cos 9 over x must equal 0, and you should write it's because of the squeeze theorem.